Welcome back, chemists, and now we're going to be looking at the reaction with metals and acids. And once again, we've encountered this reaction so many times, but it's always good to go back, revise, test your memory. Remember, in all the videos I've been doing with you and the ones to come and all the videos on study, remember the key fundamental thing about learning is that you need to revise frequently, you need to test yourself, you need to challenge yourself, and from a lot of different modalities, which is like drawing, hearing it, speaking it, teaching it to somebody. Okay, so this is why we keep coming back to these, but also just add a little bit of extra spice and new information. So let's have a look at this one here. This one here, it says about metals and acids. Now notice the plural here, acids and metals. So of course we've got to look at a variety of those cases and constantly challenge yourself. So here are some pictures here that I made in the lab where I got some magnesium ribbon in some HCl and I got it in different molarities. So you can see 0.1, 1, 2 and 4. And you can notice that there is an increase in reaction rate. And so the bubbles of hydrogen gas are just forming on this one. They're forming a lot faster still, and absolutely extremely vigorous. So we know therefore that if we were to write a reaction for this, because we have to write predict the products and we write balanced equations, that if I have magnesium solid and I add that to HCl, then that is going to make a salt, magnesium chloride, and it's going to make a gas. Okay, and remember this little video we saw previously? Well, remember that as the pop test, right? And we're going to look at that in the next slide. But let's just revise ourselves. Remember what's going on when we did module, I think it was a module 2, where we looked at different types of reactions, and we said, and we delved deeper into this reaction here. And what we found out, if you remember, that this reaction was an oxidation reduction reaction. Because what we had here, and let's see if we've got a little bit more room. So if I'm just going to copy this here, okay, and I'm just going to give myself a little bit more room here by getting rid of this just momentarily. Okay, so remember we said it was an oxidation reduction reaction, and so we had magnesium solid. Remember that's got an oxidation number of 0, and then over here magnesium's got an oxidation of 2+, so we have Mg2+, and so to go from 0 to 2+, it had to lose 2 electrons. So that was an example of, what was it? Oxidation. So oxidation is the loss of electrons. But then of course we had, at the same time of that happening, we had the H+ in the acid, and then over here we have H2. Remember, H2 has an oxidation number of 0 because it's in its natural state, so it's gone from a plus to a 0. The only way that can happen is if it gains an electron, and that was an example of reduction. And so that got us into the idea about oil rig, oxidation involves loss, reduction involves gain. And so this acid reaction here, even though we're in acid-base topic and talking about pH and color changes and all sorts of stuff, remember that a fundamental concept about acids in this instance here, this reaction, acid on metals, is an oxidation reduction reaction. Whereas when we had before acids and carbonates, that was a neutralization reaction, and acid and bases is a neutralization reaction. So this is what's going on there. Let's go to the next slide. And remember we said that we can do a test for hydrogen gas by doing the pop test, and just to remind your memory, there it goes. And remember we said with the pop test, we've looked at it previously and said if we have hydrogen gas, we combine that with oxygen gas, that's going to give us water, and that I'll put gas there because it's in the gaseous state, it's so excited rather than liquid, but I guess you could argue that vapor, liquid vapor is gas anyway. But that was energetic. In other words, an exothermic reaction, and that sudden release of energy causes the air to expand suddenly, and that's why you hear the sound, right? So in explosions, the sound you hear is from the air suddenly expanding. And remember, it's exothermic because if we have hydrogen here and we have oxygen, then over here we have water. Remember, we're breaking bonds here, and that's endothermic, but we're forming bonds over here, that's exothermic, and the bond energies over here, not that I have them memorized, but the bond energies over here is a lot higher. So remember, we're forming and breaking bonds here. Remember with the enthalpy change, that the enthalpy was the sum of the bonds broken take away the sums of the bonds formed. So we've got this side here being broken, this is being formed, and it just so happens that the energy released on this side is larger, and so therefore we have an exothermic reaction. Okay, and so this is how we do it. So since we've got some different reactions, different materials here, let's practice writing another equation, because that's what they're asking us to do. So we've got some zinc granules, so we've got some zinc here, and it says some sulfuric acid, and so we're going to make a salt, which is going to be the it's going to be the zinc sulfate, and we're going to be making the gas there. And let's just check to see if it's balanced by doing it in different color. We've got one sulfate, one zinc, and we've got two hydrogens already balanced. So that's the classic acid on metal reaction. Remember, we can do it for other metals as well. If we had some sodium, for example, and we were to put that into acid, boy, would that be an explosion. Okay, that would be an incredible reaction, very unsafe to do in the lab. Okay, we know that with sodium, when we put sodium in water, the reaction of sodium with water is very exothermic, so much so that it causes explosions to happen. So sodium is a very, very reactive metal. Zinc is not that reactive, and so therefore this is safer to do in the lab than this one here. Okay, so that's it for metal acid reactions, and we talked about differences in reaction rate, just a bit of a reminder, but we practice what the syllabus dot point says here, which is predicting the products and writing balanced equations. Okay, see you in the next video. Right, before we go to the next video, I want you to check out more courses that we have here on our YouTube channel, which are just small snippets from the actual bigger courses that we have on theflipteacher.com. Of course, with all of our courses, we try to incorporate practical sessions. We have study cards, we have posters that you can print off and stick around your room and do a lot more. We have up to 68 or more videos per course. That's like 9 to 10 hours of material that really delve deep into the syllabus and looking at essential content, skills, mathematical manipulations, and a lot more. So if you like that, go over to theflipteacher.com and check it all out, and I'll see you in the videos.